Take 3. I'm in a very good mood though, despite all my mistakes. So this, again, what I'm getting at is the third take for this. Some of the takes, one of the takes was very long even, but I keep rambling. And before those takes, I even did a practice take without recording, and thought it was good, but we're not. So anyway, we're talking about input buffers today. I have a video out already for input buffers, but I actually got some questions about how to do like a real implementation. It was real abstract, and so we're getting to that, actually implementing into what we have going on in our tutorial here. And so it might be a little bit redundant to those, but there'll be some new stuff and covering those contexts. Not everyone's going to grab that video if they're watching through all this series here. So what is an input buffer? Well, it is a buffer for your inputs. That's maybe obvious, but that means is it gives you leeway. So if we hit jump or whatever, we'll jump. And like in a Mario game, you generally can't jump again. I don't have it set up yet. We can actually jump again. But let's say you jump, and you can't jump again until you hit the ground. So you hit it right before you land, and then you don't get anything. But if we have a buffer, then it'll keep checking our inputs. Say if we do it too early, basically too early is how it works. It'll check so many frames, and then repeat the check until everything is okay. We've landed, we're not in hit stun, we can jump or we can execute that attack. For this, it works with attacks too. You throw an attack, you mash it a few times, and if there wasn't a buffer, it would only check it after you struck and you could cancel. So it would require like a lot of just frame timing, which you wouldn't want that, especially like for jumping mechanics. You wouldn't want that. So the buffer gives you leeway, makes the game feel great. In a lot of newer games, it seems like they have sort of a state buffer. I've talked about this before. There's that common, make sure I'm recording okay, situation. You're playing Dark Souls, things are getting intense, you start mash and roll. Phew, you get out of the way. But oh no, you've stopped mashing, but another roll comes out and you've boned yourself and you die. How their buffers work, I'm not sure. They're a little more, quote unquote, efficient, I suppose. Because the way we're going to be doing it is pretty brute force, but it's really low data, and I have never had a performance problem with it. Even when my buffers get really big and complex, lots of commands, I've never run into any issues. Partly because it's just one character that has it, or if you have multiplayer, then just for the players. But it's a little weird. I've noticed it in Devil May Cry 5 as well. Again, I haven't seen their code, so I don't know for sure, but it's like they store a state at a certain point when you're doing attacks and other actions. And as soon as that's done, no matter what you've pressed, if you've pressed it early on, then it stores it. And once that action's done, or once you reach a cancel state, it'll do that next action. I don't think that's quite as good. You may input something, you're sort of mashing it out, but then you change your mind, and so you want to kind of do that instead. I don't know. That's not the right way to put it. What happens is that the buffer becomes inconsistent because of that. So anyway, we're doing it this way. And it might not even be bad to do it the way those games are doing it, but I don't like it. We're going to be doing it this way, where it stores our raw inputs rather than whole states. Not sure even. I have a guess on how you would do that, but so normally, again, this is like my third take. Do right click, create C# script, clickety click, input buffer. Go ahead and make that. Double click on it to bring it up. So we have our new class input buffer. It's not a mono behavior, so go ahead and delete that if that was in there. So the buffer is a 2D array. Our first dimension is all of our buttons and our stick. So it's all of our sort of possible raw inputs. And then each one of those has the actual buffer. So it has duplicates of itself. So we're going to want another class. We'll just call it input buffer item. So we can actually call it maybe input buffer input, and then input. Wow, hold on. I was going to call it something else, and then it just got really redundant. This is why I've done like a million takes, because I keep changing my mind. So I was going to call it button, but some of it's is our sticks. So it's like input buffer input. Because the whole thing is our input buffer. These are really like wordy class names, so sorry about that, but we're gonna go ahead and do it. So again, it's a 2D array. So the first dimension is our input list. It's like our sort of raw input list. Actually, let's call it that instead. We're gonna have our stick too, but it's gonna behave a little bit differently, and I don't know quite how I'm gonna do it yet. I've been running into troubles again, so I keep redoing these takes, redoing this video. Of our raw input list, I was trying to maybe do it a little bit different, or maybe you could like go to your input here and maybe call on this. Maybe you can, but I don't want that. I like it to be a little bit more structured, and so we'll just make a new string here, and we'll just start with a few jump, attack, and dash. And then the input buffer itself is it's a list of input buffer items, so we'll just call it the button list. Call it the input list, I suppose. That's the raw input list, and then I don't know, is this bad? Who knows? New list. And then each input buffer item has a button or raw input string associated with it, and then it has its own list of the actual buffer. That's the old name I use, and I liked it better. So input state item. So this is the button associated with, it is the button. I don't know how else to say it. It's our first part of the array, the up and down. It's A, B, X, Y, start, select, things like that. And then the left and the right is going to be our actual buffer. And in each one of those, what we really need, we'll have some functions too, is a hold and a use state. You can maybe get away with just the hold state. Basically, by default, they're at 0. If we press the button, it equals 1. If we keep holding it, that just counts up. So that's going to let us determine how many frames. If it's 1, it means we just pressed it. So sometimes we're going to want it if we just pressed it. Sometimes we're going to want it if we've held it. And then if we let go, we'll make it -1. That will give us a way to check if we've released it instead. The use state is because, maybe you could make hold where like -2 equals used. But there's going to be times where you still want to know if you've held it. By making it a little more generic like this, we could apply it to our directional inputs too. Maybe we will see. I had some issue. We might just treat the directions a little bit different. I was trying to keep it pretty generic, but we'll see. But again, how the buffer works is that it checks multiple times. It checks how big your buffer is that many times per frame for old inputs that you've done. But once that gets used, we want to check that. But again, we may want to still have that data in there. So we're going to have a use state in there. And let's say, we press jump right before we land. We don't jump, we don't jump, we don't jump. Then we land. Our jumps prerequisites are met. We've pressed the button at least within the past 12 frames or whatever. Our jump state gets reset because we're grounded, and so we can jump again. Those things are still going to be in the buffer. If we didn't get rid of it, if there was like a double jump possibility, then that double jump would happen immediately because, those jump inputs are still in the buffer. So by doing used, we clear it out and we can, ignore it until we press it again or release it in a sense. So what does that all look like exactly? We're going to want to initialize this still. So in our input buffer, we're going to have an update. Whoops. And I call it raw input list instead. Because it really is an input button list, but again, we're going to have directions in there, so. I do this way wrong. I'm a little confused. Confused myself. Oh, I didn't mean to do that. I totally fudged. So I made one of those the wrong thing. So I'm going to initialize our buffer. I actually meant to do this here. Probably a better spot we can put this, but I keep making mistakes, and I'm just going to run through our mistakes. No bad programming practices, but whatever. So we're going to be updating this every time, or every frame. And then just going to have a little initialization here. We could have that in the character object, and maybe we'll fix that here, but for now, we'll just do it this way. So initializing the buffer, we're going to make a new list of those input buffer items down here. And go ahead and make a new one. For each string here. So this is our up and down. These are all of our buttons plus our stick, and we'll get to the stick part later. So right now it's just our buttons. So for each string, it's just a list of strings. We make a new item, new input buffer item. We set that button, which is a string, to that string. So we're making one for jump, we're making one for attack, making one for dash, and then we add it to this list, the input list here. When we make a new input buffer item, we also want to initialize the buffer. So we're just going to do it with a constructor on this one. So public input buffer item, it's a constructor one. Actually going to want our real buffer window. Do 12 for now. So that's the actual buffer window when you hear that in video games. It's like the length. So for 12 frames, it'll check 12 times, 12 frames in the past for our inputs. So it's real similar. I'm going to make a new list. For each one of those, we just add an input state item. So that's our actual buffer. These things are really generic, but they all need to be unique. So that's why we make so many, because the state's going to be different for each one of them. But they're all really generic in a general sense. So now we need to start updating. So this gets created. So we have, a vertical list of jump, attack, and dash, and then on a horizontal list, we have 12 of them. So we have jump going across 12 times, attack going across 12 times, dash going across 12 times. So it doesn't do much yet. We need to actually update it now. So initialize it and hit and do this. So for each input buffer item in our input list, we're going to resolve the command of that, and we'll get to what that is. So actually, we'll do that first. A lot of times I do that last, but we'll go ahead and explain what that is. So we resolve the command. So resolve command, we go through each one of these up and down and we resolve it. So if our input, this is our raw physical input from our pad and our keyboard and things like that, we just do get button of ourself, because when we created that list, we do jump, attack, and dash, and these need to match what you've put in your input, or you'll get an error. So for each one of those, if our input, is the button that we pass to it, which is our, sorry, I'm a little redundant here, but it's the one that we define up here. So when we're checking jump, if input from our pad equals jump, then we will hold up. And it's important to note, we do it at our very last spot in the buffer. So we look at our buffer here, which is kind of a duplicate of ourselves. It's our actual button state. At the top level here of this input by buffer class, it's just the button name and then the buffer itself. And so if our name gets input, if jump gets pressed, then we go to our buffer and we take the last spot in the buffer. So that's the buffer.count -1, because it's 0 index. So if we did the count, it would be greater than the actual size of it, because we have a 12, a size 12 buffer window, but 12 would be bigger. Sorry, this is like real fundamental programming stuff. 12 would be too big, because the index for the last spot is actually 11 because we started at 0. So you do -1. So if we input that button, we do hold up. So what's hold up? Well, pretty simple. Copy all these over real quick too. Hold up is if hold is less than 0, then hold equals 1. Else we increment it. The reason we do that is because we're going to sometimes we're going to hold release at -1. So if we're at -1 and just did +1, we'd actually go to 0, which isn't actually pressing it. 1 is pressing it. So if we're less than 0, then we do hold equals 1, else hold plus equal to 1. Because there's going to be two states where as soon as we press it, it will equal 1. So it seems a little redundant, but it's actually important. Release hold. So if hold is greater than 0, hold equals -1. Again, that -1 state, we don't just go to 0. We want to, there may be a case. You may not need this in your game. You may not need a release state, but it's nice to have it. And then we have that used flag again. We set that to false, meaning we can reuse the actual command of it. Else hold just equals 0. We haven't, we're not holding it. We haven't released it. Hold just equals 0. So again, if the input for that frame, is happening, if we're pressing the button that we are, the player, the person is pressing the button that we are, we'll do hold up, or we'll do release. And again, if we were previously being held, then we go to a released state, else we do to a free state, which is just 0. So that's what resolve command is. So we go through each one of our buttons and we resolve that command. If we're pressing it, we do hold up, also release it. Basically we're pressing it or not. It's a pretty easy way to do it, and all the complexities become important later. Then we update the actual buffer. So like I mentioned, we put it in the last spot in our buffer. You can do front to back if you want. I just like to do back to front. It just makes sense to me. So for each button right here, you do it for jump, do it for attack, do it for dash. We look at their buffer and we set that buffer. So again, sorry, I got over. We set it to the last spot here. And then for each subsequent one, we set it to the one that happened before it. Because we're always putting it in the last spot, it means the last spots move to the second to last spot. That spot's move forward, and then, and so on. And then the very first spot just gets forgotten because it's outside of our buffer window. So what that looks like is, again, we're doing it for each button. Resolve the command in the last spot. We actually check the current state. And then for the other ones, we go through them all. We set the hold and the used equal to the one ahead of it in the buffer. So just this buffer, the buffer, the current one, index B, B plus 1. So that, again, and we do that same thing here. We do count -1. Because count -1 is already being set here. That's our current one. That's actually, it's not the history. It's like the current state of it, of our raw inputs from the player. And then we go through and update them all. And then that happens every frame. And so when we press jump, hold equals 1. Let's say we let go within one frame. Hold equals 1 and used equals false is going to be on that first frame. It's going to go through here. It's going to be there on the last spot in the buffer. And then over 12 frames, it's going to be pushed along to the front until it's pushed out. And then when we actually check it for our commands, it's going to look through the whole buffer every frame. So this is how we update the buffer itself. We push things along. And then when we're actually looking for a command, we check that whole buffer each time. And we'll get to that. And we will visualize it here. So that was something that I meant to do before I updated here. But let's go ahead and make sure we're live. Let's do Unity, draw to screen. I forget how to do that. It's just this, right? I don't know why. I looked and I just like did this recently. I'm like, oh my god. Thought it was like. I think that was it. Oh yeah, that's the game. That's sorry, I got a little confused there. Display. Just help us visualize it. So. I'm just gonna make sure that works, make sure the buffer, actually haven't set the buffer. So normally we're gonna put that in a character, or excuse me, a player. We'll go ahead and buffer input buffer equals new input buffer. That, and then at our update input, we're going to do input buffer dot update. So, buffer dot, excuse me. Just like that. It's redundant, but I just wanted to show you that I was typing it. I don't know why. And so when we update our input, go ahead and update that buffer. And then instead of using this right here, we're going to make our own buffer check, which gets a lot more complicated. So we update all that. Then I'm going to make sure that display is actually working. Got a hello world up there. Doesn't look like it. On GUI, does that only work for mono behaviors? I feel like I've done it without it. I don't know, maybe there's a way, so I'm just gonna do it how I think it wants me to. So we're gonna go to our game engine. Wow. Is that right? That real quick. All right, cool. Now I need a way to grab that. Oh, I thought I had a way to grab this static. Okay, cool. No, because I'm just grabbing that. So we just set a static reference to ourselves. That way we can grab it from other places. All right, this just got a little whack. So when we initialize this, kind of want to do it in the reverse, but gosh darn it. Kind of confused myself. Oh my gosh. So actually what I should do, not in this update, because that's, well, we only have one, really. We should only have one running at a time. This is really bad programming, but this is for debug purposes anyway. So then in our game engine, is less than player input buffer dot count, and then for j equals 0 is less than player input buffer I dot input list I dot buffer dot count j plus so now we have our 2D array. So do GUI label I times 10 j times 10, and it doesn't matter too much what it is. And wow, please. Button plus colon here. Do I mean that? Oh, okay, cool. Seems weird that I needed that, but no. Well. So mistake there. Could have done this in a different order, would have been better, but so if I equals 0, Then we're going to put the label there based on the J's. Well, the J's is the left and right. Dudes, I'm so bad at this. So that's where I confuse myself. So I want it up and down, the Y, but I want it on the I, which is our first one. So up and down. I want here. So this one's actually left and right is J. I is 10. Or I is up and down. So we're going to list the button, and then we're going to list its input state. And we're actually going to change that a bit. Well, no, it should. Okay, we'll take a look. We'll see what it looks like. So it's a little whack. What the fudge? And then we're going to do like plus 50 just to space it out there. So, can you see that happening already? I'm going to hit jump. Go ahead and hold it. Actually, you can see it counting up. Let go. Whoops. Buffer's kind of small. So, actually, let's do it like right when I press it. So I pressed it, and then I let go. And it counts down there. This is where we released it. The next frame, you know, nothing's happening. And then once where I press it. And then I held it for, even though I was tapping it, you know, I'm only human, so I held it for a few frames and then released it. Went through, and then as we step through, those states just get pushed along. And same for attack. I'll mash that a few times. I pressed it, was holding it for a few frames, let go here, and then stopped holding it there. And then again, they just get passed through there. We can also show the hold state, which we'll do here in a sec. So we finally have a buffer, but now we have to like actually use it. So I would like to show that hold state. So what would be a good way to display that? Forget how I did it otherwise. I think I put a star on there or something. It's used. So if used, and I guess we could just add it. That would be a better way to do it, but I'm really lazy, so we'll just do it this way. Like we could have a stored text variable and then just add the star to it if we wanted, but we'll just do it this way because we're lazy. And that use actually isn't going to show up yet. But it'll be good once we start. Gosh, think I can close this now. But in typical style, it's going to be a point where I want to look at this again. So let that load, refresh, save, whatever. Yeah, it's not going to show up quite yet because we haven't actually implemented that yet. And you can see a lot of times where the inputs are happening, but my character isn't actually moving. That was that thing I've been complaining throughout the tutorials, where the inputs are a little whack. But now that we have this buffer, it's going to help a lot. So let's get into it. So our character object, we update this input buffer. And then instead of doing this, I'm going to do it a little bit differently. I'm actually going to need some help. So. And then I do update move list. So it's going to be similar. We're going to go through our move list, which we already have set up here in a sense, for each input command. In our commands, we just call it commands, but it's like our move list. I do all these other crazy checks because there's going to be priority when you have moves that, like, especially when you're making a fighting game. If you have a button where you hold one button and hit another, which I have in Citadel Deep, you generally want that one to happen first. You can order them in the list by priority if you like. But what I do is I check everything, and the priority thing increases. And then once it reaches the end of the move list, again, it's super brute forcey, but it seems to work okay. I don't have any performance issues. And then after we get to the end of everything, then it'll execute the thing that it decided was the the best thing to do. You can see how complicated this is in this game. It's actually probably pretty bad. Ours won't be so bad. So what we have here already, I think we need to delete that, is for each input command C in GameEngine.CoreData.commands, C.input string that equals Z. We'll check it only if there's actually an input happening. If our current input is equal to the input string and we can cancel, then we'll go ahead and start state. But instead of this single check, we will do a big old check. We'll check it 12 times against the buffer. So for b equals 0, b is less than. Oh, I'm not doing. Here it gets a little bit weird because using the input command instead. I may want to change this instead of for each. So I'm going to have to fix this a bit. There might be a way that I could have done this better, but so we're going to be getting rid of this and doing our own thing, but for now, this. So. Alrighty, we're getting into some weird stuff because here's where you have to like line up your like move list and like your actual buffer. Gets a little wacky. We could do a little bit different. Let me think for a sec. I'm sorry. I know this will work, but I feel like it's a little weird. Because we already have our list here of our commands. So we need to go through each command. Yeah, because we're going to need to do that anyway. So we're doing that here. And then for each command, we check the buffer. Yeah, that should be okay still. So see, that's the problem, because these aren't necessarily in the same order. So we have jump, dash, and attack. But then over here, we have jump, attack, and dash. By coincidence, they're the same. But that's where you can get into some trouble. When we're updating this data here, does this make sense why this can be weird? But anyway, we should be fine for now. So, actually, what we want to do. So we should actually be fine. I think we can just be okay with this. So we go through each command. So what I was trying to do is to sort of save a step where we go through each command and then don't have to check against, like, we can line up our commands and our buttons. And you may be able to make a game like that, but I'm realizing now that like some of our commands are going to be more complex, so we're going to kind of have to check them all against it all anyway. Like each command versus like each raw input in our buffer plus the whole buffer. So I was a little worried, but I just confused myself is really the answer here. So let's go ahead and remove this for now. So go through our whole command list. Actually want to just like undo all this. So I actually like the for each for that part. All right, so we're starting over here. So for each input command in our command list, we want to check it against the buffer. So for each input buffer item, B item, we might need the indexes here in a minute. Input list. So if C dot input string equals For now, we won't have a priority list. We'll just go ahead and do this. So we go through each one of our commands, and then in each one of those, we check the buffer. So we go for each button, and then we go for each the buffer of each one of those buttons. And if the input string of the command equals that button, and we can cancel, we'll start the state. That's not the end of it, though. I'll show you what's up. So already, it's just doing it already. Because we're going to be checking that, and that is going to be true no matter what. So now we need to take it to the next level. So if we can execute, then we'll do it. So we may have touched on can execute, but basically if hold equals 1, meaning we pressed it and it isn't used, then we return true. And a lot of times you can put used equal true here. This is going to change when your game gets more complex because this is just during the check. So we may actually want it like, in here if we actually go through, because our check here. So actually, let's go ahead and do that, because for sure we are executing here and we're breaking out. Again, when this gets more complex, we're going to want to change that. But all of a sudden, it's like I thought we had a lot more ahead of us. With more complex stuff we will, but it's hard to tell now. Let's go ahead and put our core data. Our slash test. The events in here. So we have thought it was in here. I had a cancel point. Seems like it's kind of not working here. Let me check the buffer here. It looks like she started up again already. Work anyway. Honestly, that might be working anyway. Ooh, hard to tell. You can see the use state starts working though. Did it detect my new press? Doesn't look like it did. Oh, it did. Oh, y'all see that? So that was good. So we hit our first button here. Oh, it didn't work that time. Sorry, I'm kind of slash test 2. Oh, so the cancel window is really small on that. How long is it? About 40. Make it 40 just. Well, the buffer is definitely going through there, but something is happening. It's not working. So actually, I guess I could illustrate that. So I do this move, and I made the cancel window really long, so that way we won't be able to cancel out of it right away. So if I hit first attack and hit the second one, there it worked. Well, there was a time where it was illustrating it pretty well. So right here, we have these presses here. So we're reaching the end here. Huh. That seems a little bit wrong, but maybe it's not quite that wrong. Maybe that cancel one was just too huge. I feel like it's working, but I need a way to illustrate it to y'all a little bit better. This will look okay. Well, here's the other way we can do it. Oops. That's to make our buffer window really huge. Might not even show up all on the screen. Might run out of room, but oh no, looks like we're good. See there. Hit circle and then square. I'm actually on an Xbox controller, but I don't know what the buttons are. Hit circle down here, 0. Then I did that first slash move. And I hit X, that many frames later. Or Y. What is it? It's X on the Xbox. And we're still in a can't cancel state. So we step through, and each one of these frames is checking everything for each command. And there's some redundancy here where we call it jump, attack, and dash, and things like that. It would be better if this was just A, B, C, X, Y, and things like that. But for brevity, we're doing it this way. You step through, we're reaching the end of the attack, and then I don't know why the used shows up there. It's a little weird. And we have the attack press here. So it waited a bit. Looks like we had to hit neutral for a frame. When we end a state, we should do can cancel. It was a little bit strange. That didn't seem quite right. It looks like we're lagging a frame because of that, but it may not be the case. But anyway, you can see, I'm not even holding the controller now, just because that input buffer is so long. It held it in there for 40 frames. And then we go through, we can attack again. You can hear me mashing it, maybe. And the attacks still come out. And that's what we want. We don't want a 40 frame buffer, though. That's whack. 12 should be pretty good. Now our game should feel just like a billion times better. Yeah, we're not getting any lag in any of our stuff. Although that launcher has a ton of lag now. It's kind of nice that I can do that. Let's see. I don't know if the window could be a little bigger, but just the cancel window. It's kind of strict there. You might want a little bit bigger window, or just, make the cancel frame a little bit different on this launching attack. So yeah, that is sort of the foundation of it. Let's see how long we've been recording. About an hour. I wanted to get to some more complex inputs. We could maybe do that. Again, your cancel state stuff can get really complicated. You can see, compare this here to this on my current game. It's a lot more complicated. we could set it up different. Maybe it wouldn't be so complicated. One of the reasons is there's all sorts of special conditions for when you can do certain moves. You know, there's special moves you can do out of hit stun. You got to check if you have the meter for it. There's it's just just the nature of the game makes it a little more complicated. There's a priority check. There's some other stuff I was gonna mention. Oh, there's the spot in your chain, right? So like, you know, we do XXX or whatever. The way it's set up in this game, because it's customizable, it gets a little complicated, and there's definitely room for improvement. But we could do a little bit differently. Basically, we could do, for our command lists, one way to do it is to make them nested. And so for each state, you could have nested states. And so when we check against here, we would have like a nested state index. And so if we're already in /1 and we hit / again, then we do /2 and so on. And then certain conditions would make us fall out of it. And I was hoping to get to that today. I'm just not quite sure how I want to set it up. Because right now our command list isn't really a command list. It's just our list of states. We want something a little more strict. But I wasn't quite sure. Maybe I'll save that for later. This already took a little bit longer than I was hoping. There's a lot of dilly-dallying, and sorry about that. Again, it took like 4 takes, still wasn't perfect. But already the game feels like 1,000 times better. We're not losing inputs. I don't understand that. That's why here, whoops, on dang you. We just do get button. You know, get button down and release and things like that it's just a little bit weird with Unity. But if you do get button and then calculate, interpret your own press and release thing, I don't seem to lose inputs with that. But if you've downloaded the tutorial already, or this project already, you may notice that you're losing inputs and it really stinks. So I'm just trying to think here. It would be nice to maybe set up like chains and stuff. I just don't know how the best way to do it that's not like super complicated. You know, hard coding it makes us wild. It was like, I didn't have this command list. It was just like, it was hard coded. So it's like if you pressed X, I mean, the info buffer was there. But instead of checking it against a list, it just, you know, looked through a hard coded list of things. You know, if I pressed X, then it would be punch. And if you're already punching, then it would be, you know, punch 2. If you hit dodge, you can dodge or whatever. So I think if there's anything else I'm just missing here. Of course, you know, cancel windows sooner when we hit something. And I was hoping to do, like I mentioned, those like complex inputs. That might be better for another one. You know, we do like forward, and we could do a dash, or that would turn into like a dash attack. Let me think for a sec. Sorry, this is going to be a bit of a stall, but we have all of our states. So we do have our commands here. And so what we'd want to do is, instead of, you know, if input string equals this input string, and, you know, right here, if it equals the button and we can execute and things like that, we're going to want to make like a more complex interpreter to compare those two things. You know, the buffer versus the command input. You know, how I did it in previous games was like, you know, basically it was like 66A, you know, would be, you know, those are fighting game input things. I feel like that would be a little bit too long for this video. I guess we'll just do the command list next time. I need a bit of prep time. Sorry about that. I thought I'd get to it, but I didn't think this would take this long. But it did. And maybe that'll come sooner. I don't want to make any promises, but I just don't want it as complex as I have it in my previous game. I think there's a better way we could do it. Just to have these commands to look through. We'll set up like a way to customize, basically like a script interpreter. And you can just script commands. So yeah, thanks for watching. If you have any questions, let me know. Support's been great. Been getting a lot of really positive feedback and compliments. They've been really nice. So thank you for that. If you want to support these videos or the games I make, go to patreon.com/cultureattack. If you have any questions, please let me know. Some of this didn't make sense, let me know. Oh yeah, I was just going to review it. I did this in the old video. Sorry, I always do that. Start, stop, start, stop. But, you know, we have our input buffer. And that's a collection of these buttons. And again, instead of having these, like, you know, we have these commands that are named similarly, and we want to change that. We want this to be like A, X, B, things like that. And then in our actual commands, we can script in some more complex stuff, and then we can call them different things. And then it would have not just a button. Sometimes it would just be a button, but sometimes it'll be a command like forward, forward, or back, forward. Things like that, or while jumping. And that's something I want to make a little bit easier. That's why I would like to do it in a new video, because it's really complicated and dumb how I have it set up right now. And I think there's a better way we could be doing it. But we have this list of our buttons, you know, that's the up and down basically. And then the left and right is the actual buffer. And that is a buffer item. Basically, that's just a button plus, and then that holds the buffer, which is a state of holding it or it being used or not. And then we update that on the character, on the update input. And when we update it, we just check our actual raw input from our controller. And if it equals our button, then we go ahead and do hold up, which increases the count. To put it simply, it's a little more complex than that. And then if we're not holding it, then we release it. We'll become -1. If we were greater than 0, and then we become 0 otherwise. To show the difference between just released and release state. You can count down a negative if you want, for some reason, need to be not holding it state. And then we set that all to the last spot in the buffer, buffer.count, -1. And then we update all our previous ones to, you know, the one before it. We do that, you have all these presses and things like that. And as we step through, they get pushed through the buffer. And you can see there, it got used because the jump happened again when they all became a star. And then it just clears out eventually. They're all 0. Oh, and there was another one. I don't know where that came from. Yeah, and then we have our command list that we went through in previous videos. And instead of just checking that command input equals that, here again, we're going to make this more complex. But we go through each command and then each buffer button and then each actual buffer. And then we break out if... Oh yeah, so this is only breaking out of here. We could make that more complex because we need to break out of the whole thing. I think that's where some of the weirdness is happening. That would be good to go over right now, but I'm feeling like wrapping this up. So basically, if this happened, we'd probably just have a flag here, like to start state. And then for each one of these loops, if start state will break out. So let's do it. So Oh, and then we don't have the... Alright. It would be something like that. Okay, I shouldn't give up. I shouldn't quit. I really feel like quitting. So, how can I get over that? I guess if start state would just break out. Seems weird. I usually don't have trouble with this. Yeah, we want to do it at the beginning. So that should be fine. And we don't have to do that. And again, that's going to be something that changes when our input list gets more complex. Yep, seems fine still. Isn't any inputs, super responsive. It can be a little bit loose with our inputs and things still happen. All right, cool. And basically, instead of that old check that we had down here, we check against the whole buffer. And if that's true, we'll go ahead and start the state, and we break out of this. There we go. Thanks for watching. If you have any questions, let me know. Again, thank y'all so much. It's been wonderful. I'm doing these videos, and it's fun. It helps me refine my way of approaching it. And, you know, again, knowledge is one of our core. Sharing knowledge, open knowledge, free knowledge is a core value at Culture Attack. So I hope these are useful. And if you have any questions, please let us know. Let me know. I said us, but it's just me. Thanks again, and I'll see you next time.